Hello and welcome everyone to yet another tech enthusiastic video from Edureka. Today, we will be discussing about Spark in the year 2020. But before we get started, please subscribe to Edureka's YouTube channel to never miss an update on the trending technologies in the current year. Also, if you're looking for an online certification in Big Data, Hadoop and Spark technologies, then I have dropped down a link in the description box below. Now, let's quickly begin today's session with the agenda. Today, we will be discussing about why exactly we are listening to Spark in the year 2020. Followed by that, we shall learn about the important features of Spark, and then we shall understand what exactly Apache Spark is. Then we shall discuss the important reasons to go for Spark in the year 2020. Then we shall understand the different components that you need to learn to become a Spark developer. Followed by that, we shall also discuss the important skills that are required by a Spark developer. And finally, we shall wind up the session discussing about the companies that are using Apache Spark. I hope I made myself clear with the agenda. Now let's quickly begin with our first topic. So why exactly we are even listening to the word Spark in the year 2020? Let us have a quick peek. Firstly, Spark's compatibility with various applications. Apache Spark is one of those high-end frameworks that are capable to get synchronized with numerous applications. With the rising demand for high and optimum performance, it was difficult to find out the framework that could do the same. This is exactly when we found Apache Spark that outperformed the current market requirements by integrating itself with multiple applications such as Apache Hive, Apache Pig, Mahout, Apache Scoop, Apache Ambari, H2O, Thunder, Sparkling, and many more. Advancing into the next, Spark is capable to run in different environments. Few of them are Apache Hadoop, Kubernetes, OpenStack, Mesos, Docker, and Spring. Last but not the least, Spark is capable to receive data ingestion from vast number of data sources. To name a few, we have Apache HDFS, Cassandra, MongoDB, Elasticsearch, Apache Kafka, Parquet, HBase, and many more. Apart from this, Apache Spark also has some impeccable features that set it apart from many other frameworks. Let us discuss a few amongst them. Firstly, Apache Spark's support for machine learning and artificial intelligence. So why would you want to do deep learning on Apache Spark? This is the first question you ask yourself before beginning to study the subject. And the answer comes from two parts. Apache Spark is an amazing framework for distributed computations in a cluster in an easy and declarative way. It is becoming a standard across industries, so it would be great to add the amazing advances of deep learning to it. Followed by that, there are parts of deep learning that are computationally very heavy. Distributing these processes may be the solution to this problem. And Apache Spark is the easiest way that could distribute them. Followed by the first feature, the next feature is Apache Spark is faster than Hadoop's MapReduce. Spark loads the data into memory to process it, thus speeding up the processing time as the data seek time from memory is much less than a hard disk. On the other hand, Hadoop seeks the data from a hard disk, which makes it slower compared to Spark. It has also been seen that in best cases where Spark performed 100 times better than MapReduce. Followed by the second feature, the third one says that it has efficient memory management. You must be really excited to know what makes Spark so different that it can process at lightning fast speed. Well, the credit goes to RDD, or Resilient Distributed Dataset. As the name suggests, it is the distributed collection of data that is fault tolerant, a parallel data processing structure which is best suited for in-memory cluster computation. Consistent with the Hadoop paradigm, RDDs can persist and can be partitioned across big data infrastructure, ensuring the data is optimally placed. And of course, RDDs can be manipulated using a rich set of operators. Followed by that, we can see the significant upgrades given to Apache Spark. Spark's community is one of the most active community building and debugging various Spark releases. Spark 1.2.0 was released in the mid-December of 2014, and over 1,000 commits were made by 172 developers contributing to this release. That's more than 3 times the number of developers that contributed to the previous release of Spark 1.1.1 release. As of now, we have the version of 2.4.4 which is available since the year 2018 November. Followed by that, we have the next feature which says Spark is capable to run everywhere. Spark does not have its own storage system, although most of the time Spark is linked with Hadoop Distributed File System or HDFS. It can be also integrated with another storage system like Mesos, Amazon S3, Cassandra, and many more. Spark can run using its own standalone cluster, Hadoop, etc. We have also found that Apache Spark has an efficient way of handling iterative algorithms. Apache Spark is great at handling programming models involving iterations, interactivity that includes streaming, and much more. Whereas MapReduce has shown various inefficiencies in handling iterative algorithms. This is the main reason for Spark replacing MapReduce. Spark is still a new technology and it has yet to fully sprawl in the big data market. Spark is growing quickly amongst many top-notch companies like Yahoo, Adobe, Dell, Google, and NASA. Apart from those who belong to Spark community, there are a handful of professionals who are well versed with Spark and can work on it. This has created soaring demand for Spark professionals. In such state of affairs, learning Spark can give you a competitive edge. Now that we know why exactly Spark is still the leading legend when it comes to cluster computing, let us check more about it. Firstly, its definition. Spark is considered as a lightning-fast cluster computing framework designed and deployed by Apache Foundation, which has a dedicated interface to interact with nodes in a cluster. Okay, now why should we go for Spark, especially in the year 2020, when you have many other options? I'll tell you why. Now we will understand the top 5 reasons to go for Spark in the year 2020. Apache Spark has become the most popular unified analytics engine for big data and machine learning. It was originally developed at UC Berkeley in the year 2009 by a team who later founded Databricks. Since its release, Apache Spark has seen rapid adoption. Today, most of the cutting-edge companies such as Apple, Netflix, Facebook, and Uber have deployed Spark at massive scale, and they are processing petabytes of data to deliver innovations, from detecting fraudulent behavior to delivering personalized experience in real time. That is transforming every industry. Behind these groundbreaking innovations are small but fast-growing group of talented engineers, developers, and data scientists with deep knowledge of Apache Spark. Armed with expertise in Spark and related technologies like TensorFlow, you can change the trajectory of not only your business but also your career path. To the end, there are top 5 reasons to become a Spark developer. The first one, a unified analytics engine. Part of what has made Apache Spark so popular is its ease of use and ability to unify complex data workflows. Spark comes packed with numerous libraries including support for SQL queries, data streaming, machine learning, and graph processing. These standard libraries increase developer productivity and enable teams to build robust data flows with a single engine. Additionally, Spark offers robust set of APIs with 100 high-level operators and support familiar programming languages such as Java, Scala, Python, and R to ease the development. The second important reason is lightning-fast analytics at scale. Engineered from the bottom-up performance, Spark can be 100 times faster than Hadoop for large-scale data processing by exploring in-memory computation and other optimizations. Spark is also fast when it comes to data stored on disk, and currently it holds the world record for large-scale on-disk sorting. This is critical for highly iterative machine learning, where you need to build fast and reliable data pipelines that scale to meet the needs of data scientists. From there, they are able to build and train better, more accurate models. Followed by the second reason, the third reason says that Spark is at forefront of innovation. Built for performance, scale, and fault tolerance, Spark enables teams to deliver some of the most cutting-edge big data and AI use cases. Additionally, built-in libraries for machine learning, stream processing, graph processing, SQL or data frames, and easy integration with other common tools including popular deep learning frameworks like TensorFlow and Chaos have enabled innovations across industries. Followed by the third reason, we shall advance into the fourth reason. The fourth reason says huge demand for Spark experts. Adoption of Apache Spark as the de facto big data analytics engine continues to rise. Today, There are well over 1,000 contributors to the Apache Spark project across 250 plus companies worldwide. Some of the biggest and fast-growing companies use Spark to process data and enable downstream analytics and machine learning. Recently, Indeed.com listed over 2,400 full-time open positions for Apache Spark professionals across various industries including enterprise technology, e-commerce, healthcare and life sciences, oil and gas, manufacturing, and many more. It's clear that Apache Spark experience is still in high demand, and there are no signs of that slowing down anytime soon. Last but not the least, the fifth reason is to increase your earning potential. Internet powerhouses like Google and Netflix are changing the way enterprises are approaching their business. In order to compete in a technology first world, enterprises across industries are focusing more on how to leverage big data and AI technologies to fuel innovation and their business strategies. And the value of co-workers who can enable this strategy is very high. In fact, Apache Spark developers earn the highest average salary among other programmers. According to its 2015 Data Science Salary Survey, O'Reilly found strong correlations between those who used Apache Spark and those who were paid more money. In one of its models, using Spark added more than 11,000 US dollars to the median salary. Having said that, we shall now move ahead and discuss the salary trends of Spark developers in different nations. Firstly, we shall discuss about India. In India, for a beginner level Spark developer, the salary offered is 6 lakhs to 10 lakhs per annum. Whereas, on the other hand, the average salary for an experienced level Spark developer is 25 lakhs to 40 lakhs. Similarly, we shall move ahead and discuss the salary trends of Spark developer in United States of America. In United States of America, for a beginner level Spark developer, the salary offered is in between 75,000 US dollars to 100,000 US dollars. Similarly, for an experienced level Spark developer, America offers 145,000 US dollars to 175,000 US dollars per annum. Now, to become a Spark developer, what are the different components you need to learn? Currently, we have 6 different components in Spark ecosystem, which are Spark Core, Spark SQL, Spark Streaming, Spark ML-Lib, Spark Graphics, and Spark R. Let us see what each of these components do. The first component is Spark Core. Spark Core is, as the name suggests, the core unit of Spark processes. It takes care of task scheduling, fault recovery, memory management, and input-output operations, and etc. Think of it as something similar to a CPU of a computer. It supports programming languages like Java, Scala, Python, and R, and provides APIs for respective languages using which you can build your ETL tool or job or do analytics. All the other components of Spark have their own APIs which are built on top of Spark Core. Because of its parallel processing capabilities and in-memory computation, Spark can handle any kind of workload. Spark Core comes with a special kind of data structure called RDD or Resilient Distributed Datasets, which distributes the data across all the nodes in a cluster. RDDs work on a lazy evaluation paradigm where the computation is memorized and only executed when it is necessary. This helps in optimizing the process by computing the necessary objects. Followed by Spark Core, we have Spark SQL. If you have worked with databases, you understand the importance of SQL. Wouldn't it be extremely overwhelming if same SQL code works n times faster even on large dataset? Spark SQL helps you to manipulate data on Spark using SQL. It supports JDBC and ODBC connections that establish a relation between Java objects and existing databases, data warehouses, and business intelligence tools. Spark incorporates something called data frames, which are structured collection of data in form of columns and rows. Apache Spark allows you to work with data with SQL. Data frames are equivalent to relational tables and they can be constructed from any external databases, structured files, or already existing RDDs. Data frames have similar features of RDDs such as immutable, resilient, in-memory, but with an extra feature of being structured and easy to work with. Data frame API is also available in Scala, Python, R, and Java. Followed by Spark SQL, we have Spark Streaming. Data streaming is a technique where a continuous stream of real-time data is processed. It requires a framework that offers low latency for analysis. Spark Streaming provides that and also a high throughput, fault tolerant, and scalable API for processing data in real time. It is abstracted on discretized stream or dstream, which represents a stream of data divided into small batches. Dstream is built on top of RDD, hence making Spark Streaming work seamlessly with other Spark components. Some of the most notable users of Spark are streaming with Netflix, Pinterest, and Uber. Spark Streaming can be integrated with Apache Kafka, which is a decoupling and buffering platform for input streams. Kafka acts as a central hub for real-time streams that are processed using algorithms in Spark Streaming. Followed by Spark Streaming, we have Spark ML-Lib or Spark Machine Learning Library. Spark's major attraction is scaling up with the computation massively, and this feature is the most important requirement for any machine learning project. Spark Machine Learning Library is the machine learning component of Spark, which contains machine learning algorithms such as classification, regression, clustering, and collaborative filtering. It also offers a place for feature extraction, dimensionality reduction, and transformation, etc. Followed by Spark ML-Lib, we have GraphX. Graph analytics is basically determining the relationship between objects in a graph. For example, the shortest distance between 2 points. This helps to route optimization. Spark GraphX API helps in the graph and graph parallel computation. It simplifies graph analytics and makes it faster and more reliable. One of the main and well-known applications of graph analytics is Google Maps. Last but not the least, Spark R. R is the most widely used statistical language, which comprises of more than 10,000 packages for different purposes. It uses DataFrames API, which makes it convenient to work with and also provides powerful visualizations for data scientists to analyze their data thoroughly. However, R does not support parallel processing, and it is limited to the amount of memory available on a single machine. This is where Spark R comes to the picture. Spark developed a package known as Spark R, which solves the scalability issue of R. It is based on distributed data frames and also provides the same syntax as R. Spark's distributed processing engine and R's unparalleled interactivity packages visualization combine together to give data scientists what they want for their analysis. Now that we have discussed the various important components of Spark, let us move ahead and discuss the various skills required by every Spark developer. Few of the important skills required by every Spark developer are loading data using ETL tools from different data platforms into Hadoop platform, deciding the file format that could be effective for a task, understanding the data mapping, that is, input-output transformations, cleaning the data through streaming API or user-defined functions based on business requirements. Followed by that, defining job flows in Hadoop, then creating data pipelines to process real-time data. However, this may be streaming and unstructured data. Followed by that, scheduling Hadoop jobs, then maintaining and managing log files, hand-holding with Hive and HBase for schema operations, working on Hive tables to assign schemas, followed by that deploying HBase clusters and managing them, working on Pig and Hive scripts to perform different joins on datasets, applying different HDFS formats and structure-like to speed up analytics, for example, Avro files and Parquet files, etc. And followed by that, building new Hadoop clusters, maintaining the privacy and security of Hadoop clusters, fine-tuning of Hadoop applications, troubleshooting and debugging any Hadoop ecosystem at runtime, and lastly, installing, configuring, and maintaining enterprise Hadoop environment if required. Let us discuss the major companies which are using Apache Spark. Some of the major companies that are using Apache Spark are Adobe, CGI, CSC, Capgemini, IBM, Oracle, SAP, Accenture, Twitter, Yahoo, Facebook, eBay, and many more. Now, I would recommend a few articles based on Apache Spark and PySpark. First is the RDD in Apache Spark, which gives you a detailed description of what exactly is an RDD and how to implement it. Followed by that, the data frames in Apache Spark, which will give you a brief understanding of structured data processing using Apache Spark. Last but not the least, the PySpark RDDs. The links to all these articles are mentioned in the description box below. I hope you go through them. Also, if you're looking for an online certification in Apache Spark and Scala, then I have dropped down the link in the description box below. Edureka is providing Apache Spark and Scala certification training, which is especially designed on the base of CCA 175 certification exam. The salient features of Edureka's Apache Spark and Scala certification training program are instructor-led sessions, real-life case studies, assessment, lifetime access, 24/7 expert support, certification, forum, and cloud lab. So with this, we come to an end of this particular session on Apache Spark in the year 2020. If you have any queries related to this session, then please write to us in the comment section below. Till then, thank you and happy learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!